is how to name and recognize angles and find the distance between 2 points. How to name and recognize angles. Angles is a hard word to spell. A lot of people accidentally spell it angels, right? So make sure that we are spelling angles correctly. How to name and recognize angles and find the distance between 2 points. And I'll bet you know what an angle is, but you might not know how to define it properly, right? And I did ask everybody to get a couple of highlighters. Again, you can borrow with a neighbor and all that stuff, but you're going to trust me that I'm a visual learner, and maybe you are not a visual learner, but geometry is tough if you don't see what's going on, right? I've rearranged this slideshow to be a little bit different than your worksheet because this angle right here is way down at the bottom of the screen, but you can't see it unless I bumped it up. So it's on your paper right there, but you see this angle right here? Let's define what an angle is. An angle is like two rays that share a common endpoint. Two rays that share a common endpoint. And for those who are watching this on the video, I'm going to pause and start and pause and start. If I go too fast for you in video land, you just pause your video and write down what we did. So two rays that share a common endpoint. Would you grab a highlighter? And do you see how I highlighted? I have a green ray right here. I don't care what color you choose. Just pick a color. And then highlight the other one like a different color. What I'm also learning is this TV is very hard for some people to see certain colors. If you can't see something, please let me know and I will tell you what it is. But we're going to highlight them one color. And I need your help. Could you name this green ray for me, just like out loud? What would be like the name of that green ray right there? Ray AB, right? So let's kind of like write that down right here, like ray AB. I'm going to use green to match it up. Ray AB was the green ray. Remember, we need the ray bar above it. Tried to switch it to green, but it didn't work. So ray AB, remember the ray bar? And who is the red ray? What would you name that red ray right there? Ray AC. Do you see they have a common endpoint, right? Who is the common endpoint between ray AB and ray AC? A, right? How do you feel about that? A is the common endpoint. Well, an angle is broken down into parts. The sides of the angles are the two rays that make up the angle. The two rays that make up the angle. The two rays that make up the angle. And you don't have to write this stuff down twice. I only wrote it down a couple of times because it disappeared from the last slide. So the two rays that make up the angle, we just talked about them there, ray AB and ray AC. And then the cool thing is the big boy of who we talk about a lot on an angle is called the vertex. The vertex is the common endpoint. The common endpoint. That common endpoint is the vertex of our angle. And out of all our guys, we had ray AB and we had ray AC. Didn't you just tell me that the common endpoint was A? That is the vertex of these angles. So a lot of the stuff we're talking about today you may have heard of before. We're going to fine-tune some of the knowledge that you already know. I definitely know a lot of the words we talked about you've heard before, but we'll get a little bit better. But the hardest part, besides finding an angle in the picture, is naming an angle. So there's two different types of angles that you got. You have a single angle. If you see the first one up here, like, you know, he's just like the only angle in the picture, right, you know? That's actually not that bad to name. So, like, I'm going to make it easier. And sorry, I'm just going to kind of pick on some people that I kind of know. If I ask this, if I just said, hey, EJ, you got a detention. Raise your hand in here if your name is EJ. There's only one person in here with the name of EJ. So would you believe I did not need to call that person by their full name? If I just said EJ, everyone knew who I was talking about. Maybe you didn't know the person's name, but it was not you. Are you with me on that? It was not you unless your name was EJ, because she is the only person in this room with the name of EJ. Rock and roll? This angle right here is called a single angle. You can name him and just call them by their first name. Could you tell me who the vertex of that angle is again? Who is that? A. We could call this angle A. Bad part is you can't just put a capital A, because doesn't that mean it's a point, right? So we have a symbol in front of it that you've probably seen before. It looks like this. It looks like the less than symbol that we make in algebra class. But I hate that symbol because it looks like a less than symbol, so we'll always put a swoop through it like that. That is the angle symbol. This right here is called angle A. Are you with me on that? That's just calling somebody by their first name because they're the only person in the room with that name. That's the only angle with A for a vertex. But you could also call them by their full name. Like, do you see how we had our colors in here? This was the green ray, and this was the red ray. So isn't A still the vertex? If you call them by their full name, you would do angle, and then you use 3 letters, but the vertex has to go in the middle. So I could call it angle BAC. Do you see how I put, like, A in the middle? Right? Are you with me on that? I call it angle BAC. What's the other way to name that by 3 letters? A's got to be in the middle, but not angle BAC. What's the other way to do it? Angle CAB. And what I'm going to help you guys with, because I know we're all new at this, is how to say it out loud properly. I totally appreciate that you said CAB. You do need to say angle in front of it, right? So like angle CAB. Does that sound cool? You know? So that's naming it like by its full name. That's the full name of that guy, but sometimes they have a nickname also. It's like they just totally have a nickname. Do you see the 1 inside of this angle right here? Like it's not measuring 1 degrees. It's just like you could also call that angle 1 if you really wanted to. Sorry, I hit the wrong button. You could call that angle 1. Single angles are pretty easy for us to deal with. It's the only angle in the picture. You could call them angle A, angle BAC, angle CAB, and angle 1 if you really, really wanted to. But man, oh man, oh man, I have many years experience knowing that this angle down here is tough for a lot of people to name properly. My first question is, could you in a group just discuss in your table, how many different angles do you even see in that picture? Can we agree that there's at least 3? Yes or no? Is there more than 3? There is a lot of different angles in it. There's probably 7 different angles in this picture that we can find. But you are new at this, and I am not new. You do not need to highlight, but I am just going to use my highlighter to visually show you some stuff. Check this out. Is this an angle in this picture? Yes or no? Who's its vertex? You guys down with R? Right? Okay. There's an angle in that picture. The vertex is R. Is this an angle in that picture? Yes or no? Who's the vertex? R. Is this an angle in the picture? Who's its vertex? R. Let me erase. Is this an angle in the picture? Who's its vertex? R. Is this an angle that's got R for a vertex? I could go on more and more and more. There's a bunch of different angles, but did you notice the common theme? Their vertex is always R. That's like having 20 people in a room whose first name is Dave. Everybody's name is Dave, and I go, Dave, you got a detention. And they go, which one of us? Right? Because there's 20 of us. You cannot call any of these angles angle R because there are so many different angles with R for a vertex. So let's do one together. Grab your highlighter, please. Any color. I don't care. And let's highlight this guy right here. I cannot call him angle R. But let's name him by 3 letters. Right? I need the angle symbol. Who is the vertex? I think we've got that out of the bag. Who's the vertex? R. So how about if I call him angle SRP? Would that work? Yep. What's the only other way I could name that using 3 letters again, right? Instead of angle SRP, what else? Angle PRS, right? It is, yes. It's not the angle we're talking about. The question was asked, what if we went straight across? That is an angle. We're going to talk about that in a little bit, but you're cool that it's not the blue angle that I have highlighted. But yes, it is a different angle, and we'll see how much that is in a little bit. But notice to go from S to R to P, like I had to highlight that in blue, so that's what we're talking about. Another one real quick that I was going to ask, great question. Could I call this blue angle, let me erase the orange part out of the way. Could I call this blue angle, use a pen, RPS? Is that the blue angle? Why doesn't that work, even though there's 3 letters involved? Who's got to be in the middle? R. R's got to be in the middle. Next question. Can I call that blue angle by a nickname? Is there a nickname I could call him? Is there a number on the inside of that guy? So what do you think about angle 1? Just watch for a second. What if I shade in angle 1? Is that still the same thing that I'm talking about, even though it is a multiple angle? Is that still, there's only one, angle 1. Are you with me on that? So yes, the only thing you really can't call him is angle R. How do you feel about that? Okay, so now I'm going to give you a side assignment. I don't care if you highlight this or not. Could you, in your table group, see that orange angle that I highlighted right there? Name that angle 3 different ways, please. Do it on paper. Name that angle 3 different ways. What do you think? What's one way to name this angle? Yes, ma'am, back there. Angle SRT. Is that what you said? SRT? That would be going from S to R to T. If I was to connect those together with a green highlighter, I wanted the orange one, right? Maybe it's tough to see because the highlighter didn't show up, but are we cool? It's awesome that we made a mistake. It's not quite that angle that I highlighted. I have to use either a Q, an R, or a T in those. Does that kind of make sense? So it's not easy finding angles. So I'll give you another shot at it. Can you do the orange one with those letters? What's another chance at it? I'll give you a shot. TRQ? Pretty close. What did she forget to say? I know what she meant, but what did she forget? How do you feel about that? Is R the vertex and T and Q the other letters? Love it. What's the other way to do it by 3 letters? Sir, I'm bad with names. Go ahead. Yep. Yes, angle QRT would work. And then what about a nickname? What could we call it by a nickname? Everybody. Angle. I want you to know, if you're struggling with this a little bit right now, that is normal. Some people pick it up fast. Some people are like, I still don't quite see that. We're going to get better at it if you struggle with it. But that's naming an angle. Cool. And then let's go through this. I'll bet you have seen these before. I'm going to pause and just do some stuff in class. People in video land don't need to. So an acute angle measures between 0 and 90 degrees. It measures between 0 and 90 degrees. And here's where I need some help from you. Out there in video land, if you need help using your protractor, you come see me or your math teacher, and we will help you use your protractor. But we are going to use our protractor on our geometer to measure an angle. There are so many of us and only one of me. I need patience on this with you. Can you help me out? Can you grab your geometer and look at this thing right here, which is the protractor? It's kind of weird. I want to talk about some parts of it. Can you see right smack dab in the middle of it, there is a hole on that bad boy, right? I will refer to this as the hole of your geometer. Real creative, right? Put the whole of your geometer on this. So watch this. Then you see there's also like an x-axis and a y-axis of old school stuff, but only one of those dudes has an arrowhead on it. Do you see the arrowhead? We're calling that the black arrow, right? So we have the whole of our protractor and the black arrow. What I want to do is have us all see if we can draw a 50-degree angle. How do you start? You need to draw a ray. Use the straight edge. Just the protractor has nothing to do with it. Just use your straight edge and draw a ray, and it's usually easy if it points to the right, you know. And please don't work ahead of me because there's so many of us. I just need your patience. So draw that ray, and then here's what I need you to do. Take the whole of your protractor and put it right here, baby, on the end point of that ray. But at the same time, the black arrow needs to go on top of the ray that you just drew. And leave your geometer right there so I can see it. I'm going to walk around and look at it. The hole is going to go to 50 with our hole on our dot and our ray right there. Go right there. Then you got to remove your geometer and just connect from the vertex through there. Right? So you just connect. Booyah. So it would look like this. Maybe. And here's what I want to do. I want to name that angle, angle ABC. If I want to call that angle ABC, who's the vertex? Which one? B, because he's in the middle, right? So A is on one of the rays, B's down here, and C's there. The A and the C can be in different places, but B's got to be that common endpoint. How much should we measure this bad boy to be? So we'll always put that on the interior of our angle. We'll put 50 degrees down there. That way, when you hand your paper to somebody else, they don't have to measure it. They know, oh, that's 50 degrees. And then now for the picky part, I'm going to write something down, and it's going to be wrong, right? This is what I would have a lot of newbies do, because it's not their fault. They don't know, right? It's like, I thought I wrote it correctly. A lot of people would write this: angle ABC equals 50 degrees, and that is wrong. There is no way that an angle can equal 50 degrees. Can the measure of that angle be 50 degrees, though? So there's one little trick. You've got to put this M in front of the angle symbol. The M means the measure of angle ABC is 50 degrees. And that's the hardest part about this class, is when I give you your homework today, you'll be like, I don't know what this says. If we don't practice what this stuff says, it's very, very challenging. So I'll say it, you say it. The measure of angle ABC equals 50 degrees. What's that say? Very good. It's new and it's just weird, man. If it's explained to you properly, I think we can get it. Let's draw an obtuse angle. First, let's define it. What makes an angle obtuse? It's got to be more than how much? But less than this. Do you know how much this is? It's cool if you don't know how much this is. This is 180 degrees, right? So it's between 90 and 180. That's what an obtuse angle is. Measures between 90 degrees and 180 degrees. Measures between 90 degrees and 180 degrees. That's an obtuse angle. They do a good job in middle school talking about these words, so this is stuff I knew you knew already. We're just double checking ourselves. Let's draw an obtuse angle. Let's start with a ray. Just making point to the right. And I want to measure a 120-degree angle. So how did we do that again? Because it's new. Please do not be afraid to ask. But what I'm picking up is we're getting this pretty fast, so that's why I'm moving a little faster. Put the whole of your protractor on this green dot, and the black arrow has to go on top of the ray that you just drew. Go to 120 and make you a little tick mark. Let me know if you need a little help. And then what you got to do is remove your geometer. Sorry about that. You got to remove your geometer and connect to that tick mark right there. Let me know if you need help. 120 is what I said. Yes, 120 degrees. We'll do them all together. I appreciate the fact. But then, what does this say? It doesn't say angle ABC equals 120 degrees. It says what's the M mean? The measure of it. So we'll put the ABC. Sorry, I got ahead of you. I thought I told you to call him angle ABC. Make sure we call him angle ABC. Put the 120 on the interior of that angle, and then we'll write that. My fault. I got ahead. I forgot I told you to. I didn't tell you to call him angle ABC. But I think we know what a right angle is. We were just talking about it. What is a right angle? It measures exactly 90. So I'll let you draw that next. It measures 90 degrees. Draw a right angle. Draw a right angle. Slow me down if I'm going too fast, guys. You know. So I got my angle that measures 90 degrees. There's two ways for you to show me that. You could literally write 90 degrees in there. That totally works. But I heard some people talking about it. It was like a question earlier that we didn't talk about. The reasons why I hate the way this first chapter is set up is because they ask you homework questions that we haven't talked about yet in class. Do you know a symbol that you can put in there that means it measures 90 degrees? Yeah, the little square thing. It's really called the box, right? We'll call it the right angle box. So if you wanted to put 90 degrees in there, you could, or you could put that on there. And here's what I'm going to do. I'm going to ask you to write this. I'll say it in English, you write it in math. Measure of angle ABC equals 90 degrees. The measure of angle ABC equals 90 degrees. And then what do you think about a straight angle? This is acute again, right? This is right. This is obtuse. Straight angle would be this. Measures how much? Yes. I'll watch this. I'm going to draw it for you real quick. Measures 180. What's that look like? You said it, Kane. What is this? This is really a what? It's a line, right? It's just a line. So that was back to whoever asked that question before, like could angle, was it SRT? Would that be an angle? Yes, it's a straight angle, right? Thank you for picking that up. This flew out of there. But a lot of kids have never heard of a straight angle before. They're like, oh, you mean a line? Yeah, it's a line. But we're going to have a lot of questions this chapter talk about like using a line. Do you know how much it measures in degrees? What does a line, which is really called a straight angle, always measure? How many degrees? 180. 180. And we're going to go to distance. Before you write this down, let me ask you a real question. You guys know what the interstate is here in Hays? Interstate? If I asked you to go from Hays to Salina, please don't spin the geometer. If I asked you to go from Hays to Salina, have you guys ever made that trip before? Some people may have not, but do you know what I'm talking about? I'll tell you how far that is. It's 90 miles. You with me? Hays to Salina, rough. You guys going to be cool sitting next to each other? Okay, I thought so. Hays to Salina, 90 miles. What happens when I come home? If I go Salina to Hays? Is that negative 90 miles, or does it not work that way? It doesn't work that way. Would you? Even if I drove in reverse, if you've ever seen Ferris Bueller's Day Off, it doesn't work that way. It doesn't. There's no such thing as negative distance. Does that make sense? No such thing as negative distance. So that's why we're going to define distance to be the length between 2 points. And I don't care if you write down the can't be negative in like parentheses or not. That's your choice. But I think common sense dictates when we're in high school, you can't measure something and it turns out to be negative. That just makes no sense, right? Makes no sense. So what we're going to do is I need to blow this up a little larger because my screen is so small, right? We're going to put a bunch of numbers on the number line and graph all these points. So could you do this? I made it a little bit bigger. It's still hard to see. The very far left tick mark, I put -6. Could you start with -6 and just look up here for a second? I counted by ones. The next one's -5. The next one's -4. Then -3. And then, did you see how I just listed every other one? Are you with me on that? So I want to count by ones. Start at -6. I have learned that green is a very bad color for this television and we can't see it, so I'm going to start fixing those things soon. I'm just really used to my old projector, but go all the way up to like 16 on there, and then could you plot these points on your number line? N is at -5, so put like a big fat dot and an N, and you see what I'm saying? Just like plot all those points on the number line. Cool. Here's the thing that your brain would do, because you're a normal human being, right, is when they say find the distance between point N and point P, a normal human being would sit there and count them up. I'm sorry that I keep hitting the wrong thing. Here we go. A normal human being would go, okay, from N to P, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. Would you agree you could totally find the distance that way? That would suck mathematically if N was at -355 and P was at 271. I wouldn't want to sit there and like totally count them all up. There is a formula for it, right? So if you would, there is a formula on number 2. It says, what is the formula for distance on a number line? By the way, this is a one-dimensional distance because it's on a number line, and aren't lines one-dimensional? So here's what we do. All we got to do is like subtract them. So if you would write x1 minus x2, you got to subtract them from each other. But there's a catch. I got to make sure this comes out positive. Hays to Salina, 90 miles. Salina to Hays, 90 miles. It's got to be positive. Do you remember something from algebra class that you can put around it that means it has to come out positive? It starts with an A. Absolute value bars, remember those bad boys? If you're not sure, no big deal, but put those absolute value bars around it. This formula is not even on that yellow sheet that I gave you because I kind of expect people to know it, but I might change my mind and just write it on the board. I'm still learning how good our geometry ability is, so I'll probably end up giving you that formula also. Absolute value means make it positive. Let's do a basic one real quick. What is the absolute value of -3? It is a positive 3. But what was tricky about it back in the algebra days is if I had a positive number inside of there, people thought you're supposed to change the sign of it all the time. It's like, well, is the absolute value of 3 -3? No, it means make it positive. What is the absolute value of 3? 3. You get a positive back every time. So let me slide this back up. So to find the distance from N to P, here's our last bit of language for the day and symbolism. Here's how you write the distance from N to P down. So big one. You write a capital N and a capital P right next to each other. You do not put a segment bar over it. You do not put a ray bar over it. You do not put a line bar over it. You do not put an angle symbol in front of it. It's weird because a lot of kids think, I thought 2 capital letters next to each other meant you're supposed to multiply them together. That's if they're lowercase letters in algebra. These are capital letters. So this, we're going to say it together. I'll say it, you say it. This right here says the distance from N to P. What does this say? Thank you for saying that. Here's what we'll do. This is the work shown that I want to see. The distance from n to p equals absolute value of, what's n's value on the number line? Where is n located at? So we'll put a -5 right in there. The formula says you need to subtract them, so I will have a subtraction symbol next. And then p is at 3, is that right? P is at 3. So I will put a 3 right there, and then I'll close my bars up. You see that I just had the two x values. All those means is where are you on the number line? N was at -5, P was at 3, right? And I subtracted them. So now I got to clean up and do what's in there. I'm going to write to the side because it's hard for people to see what I write down, and I'll erase. I need to do what's in here. What's a -5? Take away 3. You can totally use a calculator if you need to. What is that? It is not a -2. That would be if you added 3 to -5. It is a negative, how much? 8. It's no big deal if we mess that up. But if you lost $5 and then you lost $3 more, you have lost $8 in that case. So -8. But there's no way that that distance can be -8. What do the absolute value bars mean? The distance from n to p is really how much? 8. And we did that by counting it out, right? You know, we totally did that. Please organize that to work down a little bit instead of across like I was, if there's room. So I'm going to erase, and let's try again. Can you find the distance from m to s? I need you to write it like this. That says the distance from m to s equals. Put you the absolute value bar, and let's figure out where m and s are located. Where is m? Is at 0? Is that right? And s is at 7, and you're supposed to subtract them from each other. Inside the bars, 0 minus 7 is -7. So the distance from m to s is the absolute value of -7, which we usually just call that how much? 7. Can you find the distance from m to t and write it the way I was asking you to write it? Uh-oh. There's a problem on this one. M is at 0. And I wouldn't call it a problem, but I would call it the old oops. Isn't the symbol supposed to be a minus? And t is at what? -3? Oh, no. If I totally say it out loud, I would say 100% of math students at Hayes High would get it. What's minus a minus? We know that it's a plus, but sometimes we go too fast and we forget about it, right? You know, like minus a minus does turn into the plus. I'm so sorry, I keep hitting the wrong button right there. So how do you feel about the distance from m to t equals absolute value of 3, which the distance from m to t equals 3 in that case? Cool. You got to clean up what's in the bars first, then you can make it positive. People have asked good questions. They're like, doesn't the -7 become positive because it's in the bars? You have to do what's in there first. It's like the order of operations. You have to do the 0 minus 7 first. What do you think about one-dimensional distance? Easy? A lot of work for nothing. But let's do some two-dimensional distance. Hate this question. Remember, I didn't design these worksheets. I hate this question. It's a waste of our time. We're going to do this the fast way instead of the long way. Yes? Here's what we're going to do. Could you plot A? Could you plot B on that coordinate plane right there? A is at -5, -6. -5, -6 is where A is. Put a big fat A next to it. And B is at -1, +6. So put a big fat B next to that. Then take your straight edge and connect those bad boys together. And would you agree that finding the distance between those 2 points is what this question would ask us to do? It's not as easy as before because it's not on a number line. It's on a coordinate plane. And a coordinate plane has 2 dimensions. It's got the x-axis, which is kind of like length, and it's got the y-axis, which is kind of like width. It doesn't have 2 of the 3 dimensions. That's why it's called a plane. I mean, yes, you could put your ruler on top of it and literally measure how long it is, but I guarantee you, I graphed the same thing you did, and mine's way longer than yours is because isn't mine blown up bigger, right? So it's just because it's on a graph doesn't mean everyone's is going to be the same length with a ruler, but it will be like mathematically. And what we're going to do, instead of discovering the formula, I'm going to give you the formula. Did you get a yellow card? Can you find the section of your yellow card that says linear? There's two sides to it. Find the linear. And then what I need you to do is see if you can find the distance formula. Do you see the distance formula? This is way easier than you think it is once we learn the pieces. But what I'm going to have us do is write it down first. It's on your sheet if you need it. But we're going to do this. What does this capital A, capital B mean right next to each other with no bars over it in? Starts with a D. What does it mean? Distance from A to B. Please write this formula down on your paper, even though it's on your yellow card. Sorry. So it is the, oh man, what does that big symbol mean right there? Not squared, but square root. It's been a while since you've seen it. I totally get it. The square root of x sub 2 minus x sub 1 in parentheses. And then I'm going to start saying that properly. You say in parentheses as quantity. So like the quantity of x2 minus x1, you see how they squared it, plus y2 minus y1 as a quantity, and it needs to be squared also. I think I accidentally erased that. And you got to believe me, this is way easier than it looks after we do a couple. Do you see these 2 points that are on your paper right here? I blew them up larger so you guys can see them instead of my little tall screen. Could you do this? Could you, one more time. Could you put a x1, y1 right above the -5, -6? And could you put a x2, y2 right above those? That's how ordered pairs work. Ordered pairs are always x comma y, but since there's 2 of them, the first one's going to be x1, y1. The second one's going to be x2, y2. And let's substitute this in together. Please don't work ahead of me. We're going to say the distance from A to B equals big old square root sign. Who is x2? -1. Formula minus x1, which is a -5. Oh my God. Minus a minus. What does a minus become? Plus. Do you see how that needs to get squared? I know you're getting tired. Hang with me. x2 minus x1, the minus and minus became a plus, quantity squared. The symbol in between is a plus. Then who's y2? 6 minus a -6. So shouldn't that be another +6, quantity squared? Are you cool with like where I put the numbers and why I put them? Now I'm going to give myself a little more room to write here, so I'm just going to put this box over it. Here's what we'll do. We're going to do the first one the long way and see if you hate it. And I hope the answer is yes, because I'll show you a faster way after we do the first one the long way. So we're going to bring the distance from A to B down. Big old square root sign needs to be around it. I am serious. If you do this without that big old square root sign, you're going to lose a lot of points. I need to do what's inside the parentheses first. That's what the order of operations tells you. So right there that I have highlighted in blue, what is a -1 plus 5? You are totally fine to use a calculator if you need to do that. What is a -1 plus 5? We got 4. It is still in parentheses, and it is being squared. Just making sure you're cool with where I got the 4 from. Plus 6 plus 6. What is 6 plus 6? It is still being squared. Are you with me on that? Then it's been a while since you've squared something. That doesn't mean you're taking it times 2. It means you're taking it times itself. If you need to use a calculator, no problem. 4 squared is not 8. It's 4 times 4. What is 4 times 4, baby? So we're going to bring this down. Sorry, distance from A to B equals the square root of, that is a 16. And then 12 squared, I'll let you punch that in if you need to. Show you how to do it. You bring your calculator up, and you hit 12, and then you hit your squared button. If you're not sure where that is, I will show you, but I'll let you punch it in. It's 12 times 12. By the end of this year, you will have your first 15 perfect squares memorized also. I'll show you how we'll deal with that next week. What's 12 squared? 144. And then we'll add those together. I need to take 16 plus 144, and being quite honest with you, that's where I use the calculator the most, is to add stuff together. You know, that's what the calculator's for. If you need a calculator, there's more back there. How much is 16 plus 144? 160. The wrong answer to this question is people think the distance from A to B is 160. It is not 160. I forgot something. What still needs to go around the 160? The square root. Then the next question is, does the square root of 160 come out nice? I will punch it in, square root of 160. And I want to know if it came out nice or did it come out decimally? Not nice. So we are going to leave him the square root of 160. I will show you, if you have one of those blue calculators, if it's giving you a weirder answer. It's like, I don't know what my calculator is doing. I will fix your calculator for you in a little bit. But bro, that was only one example. We need to do two more to get good at this. So here's two more that they ask us to find the distance from. Can you even see that? That's so new. Are you cool that that's what the question asked you? They said find x, y, but that's you reading it in English. If you read it in math, it says find the distance from x to y. Are you with me on that? That's the hardest part. I don't even know what they want me to do, right? Find the distance from x to y. So here's your lifesaver. Trust me, 20 years of experience. X1, Y1, X2, Y2. If you put those little things above it at first, once you get good at it, it's fine. But if you do that at first, ain't no way you should put them in the wrong spot, because I'm giving you a formula card, right? So let's see if we can put them in. I can't use distance from A to B, though. Aren't they talking about distance from X to Y? So we're just going to use the right letters. Let's sub them in. It starts with a big old honker radical. I'm still doing this one with you because it's only our second example. Who's X2? X2 is 7 minus X1, quantity squared, and slow down because I'm going to show you that shortcut now, plus Y2, who is how much? 8, minus a minus 4, so doesn't it turn into a plus? I know we're tough getting back into the groove of school. Does it make sense why the plus shows up every once? Because it's minus a minus. Here's the shortcut. If you don't like this, you don't have to do it. You could totally do it the way we did back here, but this was too much work, in my opinion, because I think we're doing awesome at this. I think we could handle doing 2 steps at once. So watch this. You need the distance from X to Y with a pen and not a highlighter. You need the big old square root symbol, but see if you can handle this. We have to figure out the 7 minus 1, right? How much is 7 minus 1, baby? It is 6. But then doesn't it immediately get squared right after that? What is 6 squared? I'm sorry, I keep hitting the wrong button, guys. I'm totally cool if you just go straight to 36 right there. You figured out it was 6, and then you squared it. Plus 8 plus 4 is how much? 12, and then you need to square it. What would that be? 144. Do you see how I killed 2 birds with 1 stone right there? If you don't like it, you can go back and put this and this right here. Are you with me on that? You know, so we'll do that. But I got to add 36 and 144 together. So 36 plus 144, I'll let you punch that in. Thank you for that. Double check you, because not that I don't trust you, but I just like to double check. I also got 180. Are we cool with that? But the answer is not 180. The distance from X to Y is not 180. It is the square root of 180. The question is, does that come out nice? A lot of us know our perfect squares. We will definitely know them soon. If I took the square root of 180, that does not come out nice. So we're leaving it like that, square root of 180. Let's try one more. Let's see if we can get him set up with the X1, Y1, and the X2, Y2. And can you get them subbed into the formula properly? Check yours with mine. Don't copy me. Do it yourself. This is the distance from R to Q, so I'll use those letters. And get them subbed in. Yes. Give me 2 minutes, and then the answer is yes. Is that okay? Can you wait? Thank you. And then the reason why I'm having him wait is because I want to double check. One, did we get the numbers in the right place? Please double check me also, because I got a little distracted there. Did I get the numbers in the right place? And now are you ready? Here's the real reason I had us pause. Let's do this right here. -1 minus 3 is how much? That's not the challenge, but what is -1 minus 3? It is how much? -4. The challenge is, what's -4 squared? Okay. They say positive 16. But if I punch it in like that, my calculator says -16 because I punched that in wrong. Doesn't the -4 need to be in parentheses for this to work out right? And I know that our brains are actually smarter than the calculator, because I heard you guys say it, a -4 squared means a -4 times a -4. But if you're going to use your calculator to punch something in, maybe it was like -17 squared, you got to put it in parentheses, or just don't put the negative part. Does that kind of make sense? But like, it's got to come out positive. This is distance. That's why there's a squared in the formula, because stuff has to come out positive, right? So that is 16 right there. Are you with me on that? Plus, what's 4 minus 7? -3 squared, positive 9, right? It's a negative times a negative. And then the last thing here is add those up first. 16 plus 9, I'll save you a little time, is 25. So the answer is the square root of 25. Does that come out nice? What is the square root of 25? It is 5. What do you think? So I will let you go to the bathroom, but I don't like our homework. And we're going to do like the front side of our homework kind of together, which will take us maybe 5 minutes, you know. And then the back side of the homework is your true homework. Can you wait 5 more minutes, or if you got to go, you got to go. I'll let you go. Okay. Let's hand out some homework.